Now we're gonna do question number 9. Now, question number 9, it reads as follows. It says a researcher investigates the relationship between the pressure and the volume of carbon tetrachloride gas, which is given by CCl4 at a temperature of 200 degrees Celsius. The researcher varies the pressure and the researcher varies the pressure and records the volume of the carbon tetrachloride to obtain the following results. Now here we are talking the ideal gas laws. Now we spoke about the 3 guys. There are actually 4 of them. Okay, you'll see that maybe when you get at the tertiary. There are 4 of scientists that has contributed to this ideal gas laws. Gas law. We have Boyle's law, Charles's law, and the Gay-Lussac's law, right? And there is Avogadro's law. Avogadro's law, I know you know Avogadro's constant when we do the stoichiometric calculations, but apparently Avogadro, he also contributed under the gas laws where he used the number of moles. So you are only going to talk about only 3 guys, okay? So now the moment when you see the variables that are being investigated, you're supposed to understand which law are we talking about. For a fact that we are talking about the pressure and the volume, it's simple. We are talking about the Boyle's law. When you see pressure and volume, that means the law that is being investigated here, it is called Boyle's law. Okay. So, and again, we know that when we perform Boyle's law, the temperature must be kept constant. So meaning the temperature at which this experiment, we had experiment number A, experiment number B, experiment number C, experiment number D, as well as experiment number E. So what happened in these experiments is that the pressure and volume were investigated. This investigator or this researcher, he wanted to see what will happen with pressure and volume as the change is taking place. So now this is what is the end. You have to bear in mind the temperature is kept constant. The number of moles is kept constant. You can think of ideal gas equation, PV is equals to nRT. I've been dealing with this a lot. So we are investigating these 2 guys over here. So that means all of these are kept constant. The number of moles will be kept constant. The temperature will be kept constant. That means the temperature that is going to be used, they're going to keep the temperature of 200 degrees Celsius constant throughout the experiments A, B, C, D. But again, what will be kept constant? The number of moles. But how are they going to keep the number of moles constant? You see, the thing is, they are using gas. So for them to keep the number of moles constant, they have to use an enclosed container so that the molecules do not escape to lose the mass. So it must, the investigations A to E, they must take place under a closed system so that there is no escape of number of moles. So there we had a container for experiment A, B, and C, and then they changed what they changed is pressure, okay, and the volume was recorded, or either way. So what is the name of the law under investigation? 9.1, the law under the investigation, it is called the Boyle's law. It's called the Boyle's law. Okay, it's called the Boyle's law. As I explained. And then 9.2, it says to us, write a suitable investigative question for this investigation. When you talk about the investigative question, we are talking about what is the aim of this experiment? Like, what do we want to do? Literally, we can see, guys, we want to investigate the relationship between these 2 guys, pressure and the volume. So how to get the investigative question? You go reread your statement again so that you can understand what is happening, maybe if you are lost. The investigative question, it is the aim. What do we want to do? What is this researcher want to do? That's the investigative question. So they say to us, a researcher investigates the relationship between the pressure and the volume of carbon tetrachloride at a temperature of this. Literally, this is what investigator wants to do. The researcher wants to determine the relation. So how do you form a question? The question will be, what is the Now you're going to talk as if you are a researcher. So now, what is the investigative question of this? What is the relationship? Is the relationship between what? Between the, the pressure and a volume of a carbon tetrachloride in an enclosed system at constant temperature. This is an investigative question. But for a fact that it's an investigative question or it's a question, right, it's supposed to have a question mark at the end. It's very important to have a question mark at the end. Trust you me. It's very important to have a question mark at the end because you are not writing a statement, you are writing a question. So make sure that your question mark is there. So this is how we write the investigative question. Literally, you go back to your statement. If you are lost, you go back to the statement. You ask yourself, I'm an investigator. Now you're going to put yourself in the investigator, the researcher's shoes. You're going to be like, what am I trying to do here? Oh, I want to investigate the relationship between the pressure and the volume of a carbon tetrachloride in an enclosed system at a constant temperature. Yes, you're going to say in an enclosed system. Why? Because the number of moles are supposed to be kept constant, okay? So that this is a gas, and we know that gas can escape, right? Gas can escape if the system or the container, it is open. So we're supposed to close it so that there is nothing that escapes out of the system so that the investigation can be fair. Does that make sense? I hope it does make sense. Now we move to question number 9.3. Now 9.3, it says to us, give the reason why the investigation must be conducted at high temperature. And this is a trick question. I love it. Give a reason why the investigative question, the investigation must be conducted at a high temperature. This boils low into the. This is the reason. Number one, what are you dealing with? You are dealing with a gas, right? How many states of matter do we have? 3. In fact, there are 4, but 3. You have water, you have liquid, solid, and gas, right? So for us to maintain gas, what do we need to do? We need to keep our temperatures high so that, we know that at high temperatures, the molecules will be at a gaseous state. But when we drop the temperature, what will happen with the gaseous molecule? The gaseous molecule will condense, and that gaseous molecule will condense to form water. So we don't want to investigate the relationship of pressure and volume between water. We want to investigate the relationship between pressure and volume of a gas. So for us to keep the molecules to be at the gaseous state, we need to work with high temperatures so that they can remain at the gaseous molecule, at the gaseous state. So they say to you, give a reason why the investigation must be conducted at high temperature so that the molecules can remain at gaseous state, or to avoid the condensation of the gaseous molecule. One of the two. So you can say to avoid the condensation of gaseous molecules. We want to avoid this as much as we can. That's why we work with high temperatures so that our molecules can remain at gaseous state. We don't want condensation. Remember, condensation is when gaseous molecules combine together to form a liquid. We don't want that. So hence why we keep our temperatures very high. I hope that was clear. 9.4, it says to us, for the results obtained, these results, the first volume reading, which is experiment A, is correct. They are telling you that this is correct. While one of the remaining volume reading is incorrect. We don't care about the pressure. Pressure is correct, but there is a volume that is incorrect here. From here to there, there is a wrong volume over there. You need to be able to see you need to be able to see how is it wrong. Now they say to us, for which result in the volume reading is incorrect. So is it B, C, D? Give easy, give easy, give easy. So between B, C, D, and E, which one is incorrect? So is it A? A is correct. Is it B, C, D, or E? Now we're gonna have a look. They said volume, not the pressure. So that means the pressure, it is correct. We can see that the pressure from 15, 20, 25, 30, 35, the pressure, it is within the same intervals, right? And it is most definitely increasing. So when you have a look at this is what I want you to do, because some of people, like, it's hard for them to track these things, okay? So now I'm gonna show you something, okay? Now, this is what is happening. Look at the difference between here and here. The difference is very high, okay? The difference is very high. Look at the difference between here and here. The difference, it is also high. Look at between here and here. The difference, it is also high. Now, this is what is happening. The volume that is incorrect in this case, it's gonna be E. It's gonna be D, okay? Our answer is gonna be D. I'll tell you why. It's gonna be D. Now, the difference from here to here, when you say 96 subtract 88, you're gonna get 8, which is the difference supposed to be a little bit higher, a little bit higher compared to the difference when you get from here to here. Now, when you have a look at 120 and 190 and 96, you're gonna say 120 minus 96, you get 24. That's a very high difference. So we expect to get a little bit high difference between these two intervals, between 96 and 88. As much as you have a look at 88 and 68,6, you can see that the difference is also a little bit higher, but the thing is, the difference between 96 and 98 is a little bit slow. It's a little bit lesser. Hence why we're saying D, the volume of D, is most definitely incorrect. So that means to answer question number 9.9.1, for which results of the volume of the reading is incorrect, we say it is going to be D. Now, to make sense, 100% is when we answer question number 9.2.2, so that you can understand why I said that, maybe if you didn't understand what I was saying. Now, 9.9.2, it says to us, by means of calculation, determine the correct volume reading should be for the result identified in 9.9.1. Now, we're going to use the correct one. We don't want to, because we might assume this is not correct, blah, blah, blah. So let's just use the correct one, okay? So when you talk about remember, you know what, people forget these formulas. I always say this: if you forget the Boyle's law equation, you can just say PV is equals to nRT. So this is constant, so that means PV is equals to K. K is for constant. This is constant, okay? So but because we want to talk about we want to talk about two experiments, use A and D, so that means we're gonna have P1 V1, P2 and V2, because this is supposed to be the same as that one. It's a constant, okay? So that means you're gonna use P1 V1, which is equals to P2 V2. V2. What am I writing now? So it's V2. It's V2. Okay? So you can just say because when I use the correct one, I can repeat. I can just say PA VA is equals to, because I want to correct D, I'm going to say PD VD. So what is the pressure of A? And then again, guys, be careful. This is where you really need to be very extremely cautious and careful. Okay? Now, because we want it in cubic decimeters, so we can just substitute it as it is. So the pressure of A, it's 15 kilopascals. So we're gonna write it as it is. And the volume of A is 160 cubic centimeters. Now, what is the pressure of D? What is the pressure of D? The pressure of D, it is correct. Remember, it is 30. And then we said that the volume of D, it is incorrect. Now, what will be the volume of D in this case? It's what we are looking for because we want to correct it. So 150 times 160, 15 times 160, we get 2,400. And then here we have 30 VD. That's why they say you cannot do physics without math. This is like solve for X. So if you didn't do maths, how can you do physics? Now, let us divide both sides by 30. We're going to say 2,400 divided by 30. And then we took the volume of D to be 80 cubic centimeters. Why didn't we get 88? We are supposed to get 88 if we were saying this is correct. True. It is wrong because we get 80 instead. So does that make sense? Why I say D, it is incorrect. If this was 88, that means this was going to be wrong. 9.1.1 was going to be wrong. So let me show you. Okay, this is the final answer. We are done. Let me show you. If we take E, let's take E and then use the correct one. Again, we said A, it is the correct one. So we're going to say 15 multiplied by 160. And then let's take B. The pressure for B is going to be 20. And then what will be the volume? Let's determine volume of this one. Volume of B. Let's determine the volume of B. So we're going to say 15 multiplied, we said it's 2,400. And here we're going to have 20 VB. Let us divide both sides by 20. We're going to say 2,400 divided by 20. We get 120. We get 120. You see, here we get what we're supposed to get. But here we get 80 instead of 88. Hence why 9.1.1, it is now correct. You see now, that means D, it is incorrect one. Does that now make sense? So now question number 10. Question number 10 is as follows. It says to us, here it's chemical change. Magnetite is a type of magnetized rock that occurs naturally and is found in the beaks of homing pigeons and some other birds. We are learning. We didn't know about this, I know. The magnetite allows these birds to navigate using Earth's magnetic field. I didn't know about this. This is nice. Oh, apparently that's what is happening. Okay. But here we are under chemistry. Magnetite can be formed according to the following unbalanced chemical reaction. This is the formation of magnetite. Okay, it's a formation of magnetite. Apparently, when iron reacts with water, it will form magnetite and hydrogen gas. For sure, magnetite, it has iron and oxygen in it. Now, the energy diagram, this is the interesting information, basically. It's not, I don't think you're going to use it answering here, but we'll see. The energy diagram for the above reaction is given below. So this reaction that is taking place over here, you are given the energy diagram. I don't know if I told you this, how to distinguish whether the energy diagram is exothermic or endothermic. This is how you distinguish, okay? Before we can even answer this. This is how I used to do it when I was in high school, so that I do not forget. Start here and ends here. Start here and ends below this line. Here it ends above the line. So between these two energy diagrams, which one is exothermic? They can ask you that. I don't do they ask? No, they do not. So let me just do it for safety. So which one is exothermic? Is this one exothermic or is this one exothermic? Is this one endothermic or is this one endothermic? Now, this is how I do this. Ne? I say, this is where it starts, right? Here, it ends at the top. Okay, it's fine. I don't like the one that ends at the top. The one that ends at the bottom, I say it starts here and it exits at the bottom. It exits at the bottom. That's the key word. Exit at the bottom, it's exothermic. Exit at the bottom, it's exothermic. So this is how I used to do it. So that means this energy diagram is for exothermic, and this energy diagram, it will be for endothermic. If I know this is exo, that means this will be endo then. Okay, if it ends at the top, that means it's endo, and that's one. Exit at the bottom, exothermic. I just use that only, so I know if exited is exo, that means if it doesn't exit, that means it's endothermic. Okay, yeah, I used to do that. Anyways, so this is what this is endothermic because it doesn't exit, it's endothermic. Okay, all right, let me erase everything now. My pen. So now, okay, here's the energy diagram. We are given the activated complex, the activation energy, everything we are given there, right? So now, the first question it says to us, what's happening now? Okay. The first question it says to us, oh, okay. What is the activation energy of the for the forward reaction? Activation energy. What is the activation energy? Energy, the minimum energy that is required for a reaction to take place. You see that energy that will make this reaction to take place to start the reaction. That's the activation energy. Okay, so what is the activation energy for the forward reaction? They want us to calculate it. How do we see activation energy? Now remember, from the peak of your graph to the start of your graph from the reactants, this is what we call the activation energy. So 10.1.1, how do we calculate activation energy? You're gonna say your active, someday write it like this. So your activation, EA. So the activation energy, is a difference from the peak. Don't say, you see, some people, they're gonna say activation energy, it is 408. You're gonna get it wrong. You know why? This is not activation energy, it is the activated complex. 480 is called activated complex, not activation energy. So be careful. So the activation energy is this length from 120 to 480. That's the activation energy. So meaning energy of the reactants minus activated complex. Okay, you can write it even in formula to show your teacher that you know your stuff, but you don't have to. It's just for 1 mark. You can just say 480 subtract 120. It is still fine. But because you are my learners, I want you to know your stuff. Activation energy is gonna be activated complex subtract energy of the reactants. So activated complex is 480 kilojoules per mole, the units. Okay, subtract, you guys, when you get at university, you're gonna have to substitute with units. Okay, get used to that. So and activated, this one is gonna be 120 of the reactants, and then on my calculator, 480 subtract 120, it's 360. So do not forget to include your joules, your units. Sorry, it's 360 kilojoules per mole. 360 kilojoules per mole. This will be your activation energy. Or you can just write, 360. It's fine. It's 1 mark. You're not gonna get it wrong. Just that I want you to know, to see how we calculated it. Okay. Because even if it's their own memorandum, they say 360, you're gonna get confused. Where does this 360 come from? There is no 360 here, but you have to know how we did it. Okay. So 10.1.2, it says to us, calculate the heat of reaction. Oh my God, I missed things that out. Calculate the heat of reaction for the reverse reaction. Now, for the reverse reaction, you need to be a little bit careful. So how to calculate enthalpy? This is what you call the heat of reaction. Okay, yes, which is enthalpy. So you're gonna say the heat of the reaction, it's given by the products minus reactants all the time. Okay, products minus the reactants. Okay, this is how we calculate the heat of reaction. This is the formula. Here's the thing. This They literally told you, okay, this is the forward reaction, right? This is the forward reaction. The reactants, they form the products. Here we have FeH2O, which is this here. And then here we have magnetite and H2. This is the forward reaction. The reverse reaction, it's where we're going to take our product to be the reactant, because now we're going to take this as the reactant to form the product, which is our reactants, and therefore this will be the product. Now it's a reverse, not the forward. Now we're reversing it. Remember, the forward reaction number one, it is endothermic. The reverse reaction, it is exothermic. So that means we're supposed to get the negative number, by the way. Okay, so now our products, it's now this, it's 120. Be careful here, guys. I'm like, they said reverse reaction, guys. They say reverse reaction. So that means to determine delta H of reverse reaction, what is the energy of the product? The energy of the product is this one. It is no longer this. It is this one, reverse, not the forward. It's 120. Subtract energy of the reactant. It's this one, which is 270. And therefore the difference will be 120 subtract 270. It will be negative 150 kilojoules per mole. Therefore this will be your enthalpy, the heat of the reaction. Okay. I'm enjoying chemistry, guys. I love chemistry. That will be 10.1.2, and therefore 10.1.3. Now they say to us, a catalyst is added to the reaction mixture. How does this affect the heat of reaction for the forward reaction? The catalyst, okay? Catalyst, guys, it speeds up the reaction. It does not, it has nothing to do with heat. It doesn't, like, this enthalpy will remain the same shape. Well, catalyst, it just speed up the reaction. The reaction will happen faster. That's what catalysts do. Okay, so in this case, what will happen to the remain the same, Shame? It will remain the same. The catalyst has, the only thing that catalyst does, it makes the reaction to happen faster. Okay, the rate of reaction, that's what catalyst does. So remain the same. Okay, so meaning that's how we answer 10.1.3. Now I have less than 2 minutes. Let me do this and then I'm gonna do another video.